Okay, Wildcats. Today we're looking at Monday, May 6th, exact trigonometry values of special angles on page 81. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at our notes. Exact trigonometry values of special angles on page 81. Refer to page 80 for the 30, 60, 90 and the 45, 45, 90 triangle notes. Reference angles. The reference angle is the positive acute angle formed by the terminal side of the angle and the x-axis. So when looking at reference angles, you want to understand the quadrants. So the first quadrant is the values are positive for x and y. In the second quadrant, the x is negative, y is positive. Third quadrant, x is negative, y is negative. In the fourth quadrant, x is positive, y is negative. Okay. Now, you want to keep an eye on this bow tie because it helps you understand where your triangle is going to be. Okay. So if you're in the quadrant 1, triangle should be here. Quadrant 2, triangle's here. Also, when you're in quadrants 1 and 4, this value is 1. In quadrants 2 and 3, this value is negative 1. Okay. You also want to keep reference of 0, 90, 180, 270, and 360 because that's what we mean by referencing those angles. Okay. All right. If you would, go and finish up your notes. Now your notes are finished. Let's take a look at the examples. All right. Example 1. Use the trigonometric functions to find the missing sides. Okay. So here we have a 30 degrees, and that we know that this is a 60 degrees because 30 is 60 is 90 plus 90 is 180. Okay, so you want to make a 30, 60, 90 chart. Okay, and that's important because we know that 30, the side across from is x. So since 6 is across from 30, x is 6. Once we know x, we know the rest of the table. That's 6 square roots of 3, and then 2 times 6 is 12. So now we know the side across from 60 has a length of 6 square roots of 3, and the side across from 90 is 12. Okay, so AB, let's label in orange, okay, is 12, and AC, let's label in green, is 6 square roots of 3. Okay, now, same thing here. We know if this is 60 degrees, this is 30 degrees, so this is a 30, 60, 90 triangle. So we want to write our 30, 60, 90 chart. Okay, now let's see what information we have. It looks like 30 degrees is across from 90. So we can say that 2x is equal to 30 degrees, not 30 degrees, 30. Well, we divide by 2, x equals 15. Once we know that, this is 15. This is 15 square roots of 3. We already knew that this was 30. Now, so ki is across from 60, so we know that that's 15 square roots of 3. And ji is across from 30, so we know that that is 15. Okay, let's take a look at example 3. Okay, here we see that this is 45 degrees, so we know that this is a 45, 45, 90 triangle. So we're going to make our 45, 45, 90 chart. Okay, now it looks like 6 is across from 45, so if this is 6, this is 6, and this is 6 square roots of 2. So FE then would be 6, and DE would be 6 square roots of 2. All right, example 4. Okay, now again we see 45 degrees, so we know this is 45 degrees. Now it looks like 12 is across from 45, so this is 12, This is 12, and this is 12 square roots of 2. So RP is 12, and QP is 12 square roots of 2. All right, go ahead and finish up examples 1, 2, 3, and 4. All right, now it says draw and use a reference angle to find the exact value of each trigonometric function. So here we're doing tangent of 60. So we know that it's in quadrant 1. So that means this is 60 degrees. We know from our notes this has a length of 1. If this is 60, this is 30 degrees. Okay. Now, we also know that tangent of 60 degrees is opposite over adjacent. Okay. Now, we have the adjacent, which is 1, because that's adjacent to 60, but we need the opposite. Okay. Now, we know from our 30, 60, 90 chart that we can use in this problem that if this is 1, across from 60 is 1 square root of 3. So this is 1 square root of 3. So the opposite is 1 square root of 3. So tangent of 60 degrees is equal to the square root of 3. Because basically 1 divided by 1 is just 1, or I should say 1 squared root of 3 divided by 1 is just the square root of 3. All right, let's take a look at example 6. Now, one thing I didn't do on the last problem, I should probably do on this one, is this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees. And what's important is we know that 225 lies between 180 and 270. So our reference angle comes around here. And we know from our bow tie, that triangle's there. Now, you have to ask yourself is, what do you do to 180 to get 225? Well, we know that 180 degrees plus 45 degrees equals 225 degrees. So this is 45 degrees. We know that this is 90. If that's 45, this is 45 degrees. Now, we know from our notes that this length right here is negative 1. If that's negative 1, this is negative 1. Now, we know that sine of 225 degrees is equal to we know sine is sakatoa, so you might write that down, sakatoa. So sine is opposite over hypotenuse. Well, we have the opposite, which is negative 1, but we don't have the hypotenuse. To find the hypotenuse, we're going to use Pythagorean Theorem. So h squared equals negative 1 squared plus negative 1 squared. Well, 1 plus 1 is 2, so h squared equals 2. Take the square root of both sides, h equals the square root of 2. So that's negative 1 divided by the square root of 2. But remember, you can't have a square root in the denominator, so we need to multiply by this by square root of 2, divided by square root of 2. So then it is negative square root of 2 divided by 2. Okay, go ahead and finish up example 6. All right, let's take a look at example 7. Okay, now sine of 90 degrees. Now before we do anything else, we know this is 0 degrees, this is 90 degrees, we know this is 180, 270. Now this triangle is unique in that at sine of 90 degrees, that's right here. Okay, because this point right here is 0, 1. But we know that sine of 90 degrees is opposite over hypotenuse. So what we need to do is we're going to, technically there's no triangle, but we're going to make an imaginary triangle. Imagine this line's basically right there. So we know that this length is 0 and this length is 1. Okay? And we know from Pythagorean Theorem that h squared is equal to 0 squared plus 1 squared. So h squared equals 1. Take the square root, both sides. The square root of 1 is 1. So the hypotenuse is 1. So we're using this angle because there is no angle right there. So that's because that represents the 90 in this case. Basically, opposite of hypotenuse is 1 divided by 1, which equals 1. Okay. Example 8. All right, so again, we want to reference 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So, and that's important because we know 150 lies between 90 and 180. So our reference angle comes around here, and that's where our bow tie triangle is going to be. Now, the question you have to ask yourself is, well, 180 minus 150 gives us what? The answer to that is 30. So this angle right here is 30 degrees. We know this is 90, which makes this 60. Okay, now we know cosine of 150 degrees is equal to the adjacent over the hypotenuse. Well, we know from our notes that this is 1, and across from 60 would be, remember, 1 squared to 3 from our notes here, but it's negative, so it's negative 1 square root of 3. Okay, so now we use Pythagorean Theorem. We know that h squared equals 1 squared plus negative square root of 3 squared. Also, h squared equals 1 plus 3. So h squared equals 4. Take the square root of both sides. H equals 2. So your hypotenuse right here is 2. So we know the adjacent over hypotenuse, so negative square roots of 3 divided by 2. All right, example 9 and 10, you notice that they're not in degrees, so we need to convert this to degrees. Well, we know that 180 degrees is equivalent to pi. So what we're going to do is multiply by 180 divided by pi. And what that does is the pi's divide out, and then 3 goes into 180 is 60, 120, so 60 times. So this becomes 60. So 2 times 60 is 120 degrees. Okay, now we know that this is 0 degrees, this is 90 degrees, this is 180. We know that 120 lies between 180 and 90. So our reference angle brings us here. Now we know that 180 minus 120 is 60, so this is 60 degrees, which makes this 30 and that 90. Okay, now we know from our notes that this is negative 1, which makes this, because you have to be careful because of the quadrant, even though this is a negative number, we know that because of the quadrant, this would be 1 squared to 3. And we can basically use our notes from here that we know when this is 1, this is square root of 3, h is 2, so h is 2 here. Okay, so now we know cosine of 2 pi divided by 3 is adjacent divided by hypotenuse, which equals well, adjacent is negative 1, hypotenuse is 2. All right, let's take a look at example 10. So again, we're going to convert this to degrees. So we're going to multiply this by 180 divided by pi. The pi's divide out. 6 goes into 180, I believe, 30 times. So 30 times 11 is 330 degrees. So we know that this is 0 degrees, that's 90, this is 180, this is 270. So we know that 330 lies between, and this is also 360 degrees. So this lies between 270 and 360. So we reference around. No, this is 90. And then you ask yourself, well, what do you take away from 360 to give you 330? So the answer to that is 30 degrees. So this is 30. That's 60. We know from our notes that this is negative 1. And that would make this, because it's in the positive quadrant, square root of 3. We know that this is 2. Now, we know that tangent of 11 pi divided by 6 is equal to the opposite divided by the adjacent. Well, opposite of 30 degrees is negative 1. Adjacent is square root of 3. So we need to multiply the numerator and denominator by square root of 3, square root of 3. I've run out of room, so let's bring it up here. So you're left with negative square roots of 3 divided by 3. Okay. All right, that finishes up the examples. Go and start working on your assignment and have a wonderful Wildcat day.